Hey, stats class. So in this video, we're going to look at something called the chi-square distribution. So this is the first distribution that's not bell-shaped. So when we're dealing with proportions, we did the z distribution, which was normal. When we did means, we're doing the t distribution, which isn't normal exactly, but it is still bell-shaped. 0 was in the dead center. Well, now we're looking at something called chi-square. So if you go to your keypad down here and then click on functions, you'll be able to scroll down until you get to distributions. So there's z, the normal distribution, there's t, and now here's chi-square. So if you click chi-square, the first thing it wants is degrees of freedom. And just like it was in the t distribution, it's going to be one less than your sample size. So my sample size here is 28. All right, but what I want you to see, I'm going to do the same thing I did with the t distribution video. I'm going to put n minus 1 in there and give you a slider for n, and I'm going to take this from 1 up to like 100 with a step size of 1, and you can see that when I do this, I start to get this extremely right skewed distribution. All right, extremely right skewed for very low sample sizes. But as the sample size gets bigger and bigger, it becomes less and less right skewed, just like the t distribution became more and more normal shaped. The chi-square distribution does as well, but it still is going to be a little bit more heavy in the right tail than the left. All right, and the other thing is it can't go past 0 on the left end. So the t and the z both went off into negative infinity technically, but the chi-square distribution can't get below 0. Now let's apply it to just this problem. How do I find a confidence interval with a chi-square distribution? So number one, you would use this to find confidence intervals for population variance or population standard deviation. You're not going to use it for a mean or a proportion anymore because that's z and t, but for population standard deviations, if you're trying to estimate that, then that's what this distribution is for. So what we're going to do is I'm going to put the actual degrees of freedom for this problem in. So this is sample size 28, so that'll be 27 degrees of freedom. I'll just delete this. And there isn't a shift or a scale or anything like that. So once you get the degrees of freedom in, you've got your distribution. You can click the little zoom icon if you choose to. All right, and now I'm going to put in the cumulative probability. All right, and it wants to know the critical values, the lower and the left and right chi-square values. So what we want to do here is very similar to what we did before. We want to do the bounds on the inner when we're doing a confidence interval, and we want to get this percentage right. So this percent 0.98 is what it says down here, 98% confidence. And you can see that this is not symmetric at the peak anymore. That's at 25. And then down here you can see we're a little bit closer to 25 than we are way up here. So we no longer have that plus minus symmetry that we saw in the last two sections. All right, so 27 degrees of freedom, 98% confidence. This is my upper. I'll drop it down and then I'll click my lower. So there is not the confidence interval yet, but just the lower and upper critical values. Okay, so 27 degrees of freedom, and then it wants to know what are your lower and upper critical values, your left and right critical values. So this is the left one, the lower of the two. So to 3 places, this will be 879, so 12.879. And then my upper one to 3 places is going to be 963, so 46.963. Now, after you find your critical numbers, you're going to use those critical numbers as the denominators with this value in the numerator. So go ahead and type SQRT for square root, or you can click this button down here for square root. All right, but you need the square root. Now go ahead inside the square root, do a division. All right, and in the numerator, you want your degrees of freedom. You want that 27 times not just the s, but the s squared. Okay, so 0.25 squared. Shift 6 will do a square. You can also just click that button there, and that will square it. All right, so s squared times the degrees of freedom in the numerator, and in the denominator, you're going to do each of these, but for the lower one, you're going to divide by the bigger, the right denominator. So you're going to copy this, paste it down on the bottom. That's your lower number, okay? And then what I like to do is just copy everything, paste it down here, move that out of the way, paste it down on the next line, and then just replace the denominator with the other critical value. Just the denominator. So there is my confidence interval here. So rounding this to two places, that's going to be 0.19, and then rounding this to two places, I'll get 0.36. And that is a confidence interval for a population standard deviation using the chi-square distribution.